All right, so thanks for your question. I'll do my best to try and explain it to you. It might be a little bit out of context of what the question was that you actually sent me, but I think it's important to take a little bit of a step back and just see the entire concept first. So the main thing we're working with here is, look, how do we evaluate trig angles, 360 degrees around the unit circle, and particularly, how do we go, okay, well, we've got an obtuse angle, so like 120, we'll say. How do we evaluate the sine and the cosine of an angle like that? And what it comes down to is two things. Firstly, an understanding that different trig ratios are going to be either positive or negative in each quadrant. I'm not sure what you've gone through in class. This might be, you might have a bit of a different acronym, you might have a bit of a different way of your teacher explaining it. But the simplest way that I learn it, and a lot of other students across Queensland, is an acronym with either all stations to central, or you can remember it as CAST, C-A-S-T. I just like to start with all stations to central, because this is actually quadrant 1, and both sine, cos, and actually also tan are positive in this quadrant. So we know that, okay, if we just have an angle in the first quadrant here, right? So just like 30 degrees, if we just are asked to do sine of 30, that's just doing sine of 30, as you normally would with your either the calculator or you've got your special triangle rules. So they would look something like this. And again, it would be same for radians, of course. Sorry, that one's 30. 60. And then you've got your that kind of setup. So that's the first way of doing it. You just take your angle. If it's in the first quadrant anyway, you're chilling. You can just do your calculations like that or with your calculator. But where it gets a bit complicated is, okay, we don't want to find sine of 30. We now want to find sine of 120. And what we need to do here is think, okay, well, it's always a reference from this starting point. And now we're around to here. So we've clearly switched to a different quadrant now. That's not a very straight line. Yeah, so we're in quadrant 2. Two things we need to figure out is how far into quadrant 2 are we? And secondly, how does this change the sign? Not as in the sign, but as in, is it positive or negative? So 120 is going to get us 90. That's going to get us to the line there. And then it's going to be another 30 into this quadrant. But that's not actually the value we're interested in necessarily. What we're interested in is what is the angle between the horizontal and where we are in that circle. And what that's going to be is 60 degrees. But the easiest way to do that is not necessarily think about what this angle is in the first place. It's just to go, okay, let's go to my nearest horizontal reference. So that's going to be 180. And you can say that sine of 120 is sine of 180 minus 120. And then the actual verbal interpretation of this is not like, it looks strange. It's like, okay, well, you're saying that sine of 120 is the same as sine of 60. Kind of, but I think the graphical interpretation makes a lot more sense. We're saying that, okay, it's in quadrant 2, but in order to solve it, we need an acute angle. To find out what this acute angle is, we need to go from the closest horizontal point of reference, which here is 180 degrees, and then work backwards until we hit our angle. That then gives us the acute angle we're looking at. The second part of this equation is you go to your all stations to central, and you see, okay, what ratios are positive in this quadrant? In quadrant 2, sine is positive. So all we need to do is just say that sine 120 equals just still positive sine 60. And so that's fine. Where it would be different, right, is if we were asked to find cos of 120. So if it's okay, just evaluate cos of 120, take free. We've actually got to go, okay, well, cos of 120 is going to get us in the second quadrant. But importantly, with the second quadrant, only sine is positive. So your cos angle in the second quadrant is going to become the negative version of the acute angle. So we're going to go to our nearest horizontal reference, that's 180 degrees. Take away the angle we're looking at, and that'll work us backwards to an acute angle, which is 60, but we've got this negative now. to indicate, okay, this isn't just the same as cos of 60 being in the first quadrant. What's different is that we've got a negative of that original value. And so that would be negative 1 on 2. And why this is negative, because I think it's important to understand why rather than just take it at face value, is because we know that a triangle here is going to look like that, right? It's going to be a right angle triangle. If we're finding the firstly, if we're finding the sine of this angle, it's going to incorporate this side here and the hypotenuse. The hypotenuse is always going to be positive. But what isn't always going to be positive is this side and this side. In the second quadrant, this is still a positive y value. And that's why when we're using sine, it's just a positive number and another positive number. So it doesn't change compared to the first quadrant. When we're using cos though, instead of going in a positive direction with the x value, we've actually traveled backwards in a negative direction. And that's why our cos ratio is going to turn negative when we get into this quadrant, because we're using a negative value for x over a positive hypotenuse. And that's the background of why we can just blanket rule state that in quadrant 2, sine ratios are going to be positive, cos ratios are going to be negative. And so that's where the logic of, okay, we need to add this negative comes from when you're looking at manipulation of obtuse angles across the unit circle. Hope it makes a little bit of sense. I'm not entirely sure that's what you're asking, but I hope it's along the same lines. If you've got any follow-up questions, just let me know, because I'm happy to dive much deeper into this topic because it's pretty tricky. But I will say though, if you can nail this now, it'll make everything else for the rest of the year way easier, because it's something that you come back to a lot through year 11 and year 12. Cool. All right, thank you so much, and I hope that helps.